All right, ladies and gentlemen, Mr. Dorfler here again for yet another video. This time it's going to be on Newton's second law, and we are going to do a couple of practice problems that involve Newton's second law. If you watched, hopefully you all watched the video regarding the 12.1 notes, you'll know that Newton's second law basically states that force is equal to mass times acceleration. And so what that means is, dependent on the mass or the acceleration of a particular object, that's going to ultimately determine the overall force object has in a certain scenario. And so what we're going to do today is we're going to do three questions that are going to demonstrate how we can take the formula for Newton's second law and solve for situations that involve each of the three variables: force, mass, and acceleration. Now, I'm going to start off this video by simply just trying something new with my recording program. I'm going to try to see if I can't write directly on the screen itself with my mouse. If it doesn't go that way, then we'll go to plan B. How about that? So let's start off with number one here. Okay, and these are coming directly from the homework assignment that you're going to be assigned along with this video. Okay, so we have a car that weighs 3,000 kilograms and it is accelerating at 32 meters per second squared. Now, how this is written right here, like I'm going to use my little tool now, how this is written right here, you may be unfamiliar with you, okay? But what this means, it simply just means meters per second, which in reality means meters per second squared. Okay, so don't freak out if you see that. It just means this. So if you want to consider this written as this, by all means, that's fine. Okay, I'm going to erase that. All right, a little erasey tool. So first and foremost, if you look up here at the right-hand part of your worksheet here, we give you the formula F equals m times a, which stands for force equals mass times acceleration. Okay, one thing you need to remember, going back to your notes, is that force is going to be equal to the unit of newtons, capital N. Okay, acceleration must be in meters per second squared. And lastly, mass must be in kilograms. Okay. Yes, there will be some situations, and you might even see one on one of the practice questions we're getting ready to do now, where you are given a mass in grams. That is perfectly okay. So don't panic, because again, mass must always be in kilograms. You will see how we deal with that in one of our sample problems here coming up. So first of all, the reason why it's got to be in kilogram, that's not what I wanted. I wanted that. Oops. There we go. Sorry. I'm still learning all this program here. Okay. Because really, what a Newton is, okay, is a combination of the units for mass and acceleration. So really what a Newton equals out to be is kilograms times meters per second squared. Okay? And so when we need to, we can break Newton down, the label Newton down, into these and cancel where appropriate. Yes, that is a 2. May not look like a very nice 2, but it's a 2, okay? Meters per second squared. All right, let's give this a whirl. I need one of those fancy computer pens that I can kind of write with here to make this a little better. Okay, let's scroll up here just a little bit. Okay, going back to our problem here. Car weighs 3,000 kilograms and accelerating at 32 meters per second squared. What force would be if the truck struck the wall? So we've got our formula, F equals M times A. That is terrible. I'm going to try to write that again. My apologies. It's going to be a short-ish video. Okay. Force is equal to mass times acceleration. Okay. And again, so we don't have to do any rearranging because we're solving for force. It's set up for force. So all we have to do is plug. What am I doing here? All right. Don't mind me. At the end of the day, I'm trying to get this thing to work. Okay. We're actually doing number 1 here. I know what's going on. So again, back at it. Force is equal to mass times acceleration. The mass is 3,000 kilograms. Okay. Multiplied by the acceleration of 32 meters per second squared. When we put this in our calculator, we should get a pretty large answer of 96,000 newtons. And that is our answer. All right, we got through 1 magically after I messed up the problem we were working on here. Anyway, so the force that would be exerted on the wall or on the truck even when it struck that wall with these parameters would be 96,000 newtons. Again, see, I answered it in newtons. Let's do another example. This time, let's try a different variable. Okay. If I can erase this. It's going to take a while to erase this. All right. You know what? Let's just scroll up. I'll erase that later. Okay. How about that? Number 3. Number 3 says, I kick a soccer ball with a force of 15 newtons, and the acceleration is 5 meters per second squared. What is the mass of the soccer ball? Okay, so here we're solving for something different. Okay, so again, starting with F equals mass times acceleration, I need to calculate for M. Okay, I need to solve for M. And so I have to incorporate a little bit of algebra in here. I need to isolate mass so I can solve for it. And the only way I can really do that is to divide both sides by acceleration. So now I'm going to have mass is equal to force divided by acceleration. And so now I've got it set up for mass. And so I'm just going to plug in what I know. I know that I've got 15 newtons of force, and my acceleration is 5 meters per second squared. And so knowing what we said before was mass must equal kilograms, I know that's what I have to report my mass in. It has to be in kilograms. And when I divide 15 newtons by 5 meters per second squared, I end up getting 3 kilograms for the mass of the soccer ball. Okay. Let's go on to our last sample exercise here. We're going to look at number 5. Okay. This one's going to incorporate a couple different things here. Okay. I throw a softball with a mass of 2,000 grams, and it hits the catcher with a force of 10 newtons. What is the acceleration? So again, got a few things going on here. Let's look at the formula itself. Force is equal to mass times acceleration. This time, I'm solving for acceleration. So I need to isolate it. So the best way to do that is, again, a little algebra. We're going to divide both sides by mass to where I get the formula of acceleration is equal to F divided by M. Another thing here is my mass is 2,000 grams. What did we just get done saying a couple times throughout this whole video? Mass must be in kilograms. Well, there are 1,000 grams in 1 kilogram. Okay? There are 1,000 grams in 1 kilogram. So in order to go from 2,000 grams to kilogram, I need to take my 2,000 grams and divide it by 1,000 grams. Okay? And that will give me an answer or a mass of 2 kilograms. Again, I can't do anything with the force equation, even though it's set up for acceleration. I can't do anything with this until I have my mass in kilograms. So again, anytime you see a mass that is in grams, to convert it to kilograms, just divide it by 1,000. Okay? So now I get acceleration is equal to force, which is 10 newtons, divided by our mass, which we calculate as 2 kilograms. Divide those. And again, acceleration must be in meters per second squared. We get 5 meters per second squared as our answer for number 5. Okay? So there you've just witnessed 3 different problems, each problem solving for a different variable of Newton's second law, and third one even incorporating a little bit of altering the mass so that it is in the appropriate units. So your goal after watching this video and hopefully doing these 3 problems is to complete this particular worksheet. Okay? The due date for this worksheet will be posted into Classroom, so pay careful attention to that. Okay? We're going to have these uploaded back into the assignment itself, so make sure you get it up there by the appropriate due date. And with that being said, I'm going to wrap this video up. If you have any questions, feel free to get a hold of us. Thank you.